A very warm welcome and a good morning from the Grand Garage. I'm very exciting to be moderating this tech brunch number 4, which is really exciting because it's about cobots, robots, science fiction coming to reality. Again, we'll keep it very interactive. So there is a tool which is called Slido. You just Google it and you could put in all your questions under the hashtag CoMeMak and they will be answered. It will be very interactive and so we have actually introduced a couple of experts. Not all of them are here yet because one of them is still stuck in the train. And another one, Marcella, who was actually supposed to host this event today, she unfortunately is sick. But I'm representing her, and I'm very excited to welcome Jesse de Pagter. He will come up now and hand over the tool, and wish you good luck for your presentation on cobots. Yes.
Does this work as well in the stream? Yeah. Okay. So yeah, that's me. And that's the first slide. So what we will do today is first we will talk a bit about robots in general. And afterwards, Tudor and Ionesco, who is actually the one stuck in the train, will dive deeper into collaborative robots, which we tried to introduce here at the makerspace and also at some other places. Um, by doing that, we try to democratize the cobalt. So the idea is that we try to make it available to a wider public. And I want to, in my talk, which is more general about robotics, I want to focus a little bit on why we would need democratization. Why do we need this kind of opening up of robots to the wider public? And I will do this by looking at robots as a very fascinating technology. A lot of people are quite fascinated by robotics. Of all the technologies that we have around, I think robotics for a lot of people is one that is a bit scary maybe, but also very exciting. So in short, a fascinating technology.
Climate
And
catastrophe. Do you believe
in order
there
to
is a
talk about
pathway
that,
to
I
avoid that
first want to
catastrophe?
talk a
And
little bit
what would it look
about
like?
the robot as a cultural icon.
Yeah,
And
so
what do I mean by that? It's actually
I am
quite
not one of the
simple.
doomsday people, which makes quite
So I mean by that that I'm going to talk about it not so much as a technology in this slide, but more as something that that we see a lot in our culture. For example, in science fiction, also in our newspapers, etc. We have a lot of content about robots, and it's very much about this robot as this fascinating technology. And in order to introduce that, I actually have I have a bachelor in history, so I want to talk a bit about the history of robotics as a cultural icon. And for that, I go actually very far back to the Greeks. Um, because what is very interesting about Greek mythology that they, in a way, had also something that you could compare to robots. Sorry, namely the story of Pygmalion. So Pygmalion was in this mythology, so it's a few thousand years ago, was a king and a sculptor. And what he did, he sculpted a woman. And when he was done, he looked at it and was like, "This is the best woman ever. I wish she was alive." And guess what? At some day he came home, kissed the statue, kissed the sculpture, and it came to life. And often by historians of robotics, this is referred to as one of those first stories where something human made comes to life. So this idea of an object being in some way autonomous. So with a bit of imagination, you could say this is the first example of this idea of a robot Of course, they didn't have the word robot yet back then, but this idea of something automatic or something that comes to life. Um, and yeah, I want to make now a very big jump to the black and white picture, because that's actually quite interesting. Also in the cultural realm, so nothing technological. And that's the second point, namely the word robot. So the word R-O-B-O-T actually does not come from engineering. It originally comes also from the cultural realm. Namely, in the science fiction play by Karel Čapek, a Czech writer, he wrote the play about Rossum's universal robot. And um, this is a picture from that play. And what happened in this play is that humans make robots. They work perfectly for them. But guess what? At some point, the the robots start to rebel, take over, and afterwards the humans are more or less the slaves of the robots. Now, what I want to make clear here is that um, again, this is this strong image of like the robot being autonomous, being exciting, maybe being dangerous. You see this in this play. And in general, I would say nowadays in art and popular media, I just put two pictures. This is, for example, from the Venice Biennale. I was there, where this is actually a very big robot, and it was moving all day, cleaning something that is like fake blood on the floor. All that, that's what it was doing all day. And it's also the artist is playing there with this image of the dangerous robot, let's say. Okay, so like to finish this slide, the idea is that in this realm of the robot as a cultural icon, there are a lot of mystified futurist expectations of robots. Both dystopian, this is quite dystopian, I would say. They are trying to play with this dystopian idea, and also a lot of utopian ideas that robots will make the world perfect and can do everything for us. Yeah. So that is the robot as a cultural icon. And I think you would agree with me that you see this image around a lot in movies, etc. Now let's go fast through the robot as a technology. Yeah, so I was talking about science fiction, etc. before. As a technology, it's completely different. In technological development, you are limited in a way. Like in sci-fi, you can go with your imagination. In technology, it needs to work. Yeah? So it probably not a surprise that robots as a technology did not start that much in the Greek times, but in the modern times. And I would say, you can disagree a little bit about this, but that in the Industrial Revolution, so around the 1800s, with the general focus on mechanization and automation, you could start thinking more realistically about machines that are autonomous. However, talking about robots, like I said already, Karl Čapek came up with the word robot in the 1920s in a play. But the actual robotics research, as really a field of research in engineering, started more or less around the end of the Second World War. And then in 1961 is quite an important moment. This picture, we have the Unimate, which was introduced to General Motors, a car company in the United States, big car company. And from that moment on, we can more or less speak about a quite successful introduction of robotics in the industrial field. What is interesting, by the way, that this is Isaac Asimov, who was both an engineer and a science fiction writer, so they still mix a bit. And I will jump a bit fast. We don't have that much time, but in nowadays we are also talking about personal robots and social robots. So robots are even moving out of this industrial space, and we're thinking there are prototypes, etc., of having robots in our personal space. So autonomous machines that can help us, for example, in care. This picture. Also an interesting picture, the robot Sophia, a social robot, gave some kind of lecture at the United Nations. So there is a lot of development going on. In short, like if there are two technologies that make this development even faster, I would say computer vision and AI development are at the moment really developing fast. So we could see new kinds of robots appearing in our social and public life, let's say. Okay. So what we had till now was this kind of public image of the robot, this often influenced by science fiction, etc., and the technological reality. I went with big steps, but I tried to give a small summary of those two. Now, we would, of course, think they are quite separated because one is fiction and the other is reality, let's say. But they are not always, especially now that robots are more and more entering a lot of people's lives. And the issue here is a little bit that this cultural icon image actually also influences how people's opinion about robots and potentially also the interactions with robots. People already have certain ideas about robots, um, and this might influence their interaction with robots. They might be afraid of them or too excited and think that they can do way more than they can actually do. And very importantly is especially the last point. There is currently a lot of discussion. I've specialized in studying those discussions in my PhD about the position of robots in our society. So, for example, in the European Union, here, von der Leyen, our president, so to say, in the European Union, there is a lot of talk about what are we going to do with robots in the future? They might become too dangerous, etc., etc. So this idea um, of the autonomous robot being dangerous is also present, for example, in the political realm. Yeah? So, for instance, this headline in Europe, they are even talking now about introducing in the law some kind of personhood for robots. That is that's quite a step, you know, like that is a personhood usually we only give to humans, so to say. Also, this is an interesting picture, Andrew Yang, who was a candidate for the Democratic Party, but he lost against Biden. And very strong in his campaign was this idea of the robots are coming and we need to prepare. And also, I think this picture speaks for itself. So what governments are trying to do now, for example, the European Union, is a very strong focus on ethics. Yeah? So like including ethics in robotics development, etc., in order to make sure that robots do not cross any boundaries. And also, there's a strong focus on human-centered robotics, that robots help the humans, so to say, and can also not become problematic for humans. So, in short, what I want to conclude my part of the presentation with is that I'm referring again to this cultural idea. I'm not against science fiction. Like it's completely fine if interesting imaginations exist. But now that robots are more and more entering our actual lives, I would argue, but we also in the project that we need a more balanced image of robots. Like this mystification and this utopian and dystopian images are interesting, but they are not always so close to reality. Also, it would be good if people have more familiarity with robots. So if we could increase the access to robots, that people can actually work and play and maybe tinker with robots, so that they understand more about it and maybe can also help improve robotics. Like you need activity in order to make something work usually. And finally, we need human-centered ethical robots, says the EU, but in order to do that, you need more practices to know how to do that. How can we make robots human-centered? How can this become part of engineering practices, for example? So, and I think I just see the second speaker coming over there, so that's good. Um, because he's going to explain more about our project, but very short introduction. In this context, we were talking about the democratization of robots, and that fits exactly with all of those things. We need more balanced image, we need more access, and we need people to work with robots. That's exactly what we tried to do here with collaborative robots, and they are in that regard a very interesting technology because collaborative robots are very safe. You can work with them, you can touch them, you can move them, and that is exactly what we tried to do here with this specific type of robot, namely the cobot, collaborative robot cobot. Um, and the makerspace here and also some other spaces like RIC and Gunskirchen were very and are still very interesting spaces for that because they are a makerspace. We are here in a makerspace. It's very much focused on this accessibility. Any member should be able to work with the robot if they want to. Okay. Um, that was it from my side. If I could show some videos if we need some more time.
Yeah. Well, maybe I think what was very interesting in your presentation yesterday was the fact that with the statue, and no one can imagine to develop a relationship with the statue. And you also mentioned RIC, so that's a perfect transition for me to introduce Arina Lomp from RIC, who is a process engineer. And actually, we've talked a bit before, and one of the questions that you are frequently asked is whether humans and robots can develop a relationship.
Sandra. Yeah, my name is Arina. I have a master's degree in the area of robotics at TechBrunch in Finland. And now I work as a process development engineer in the company that's called RIC for Regional Innovation Centrum. This is a daughter company of a big combustion engine factory. It's located in Gunskirchen, Austria. And the purpose of this company is first to educate people who then can go and work in our factory, and or just educate general public who wants to learn more about the technology. So you can check out our website. It's ric.at. And yeah, if you want to learn something, you can go there. But the second purpose of our company is to act as a kind of a hub between innovators and industry. So between the combustion engine factory and I don't know, research institutions or universities or anyone who brings innovations to robotics. And now back to the question. I think we all develop some kind of connection and relationship with tech that we use. We swear out at our cars when they don't work as we expect. We have some kind of relationships with our smartphones and computers, and we can give them a nickname, or we always have something going on. We do not perceive them neutrally. It's just not a thing. So yes, I think that the relationship between the robot and the human is of course possible, and it is happening. In our workshop, for example, me and my colleague, we work with this mobile manipulator. We gave him a name. His name is Bender. And also when we install a robot at the workplace, then we can observe how the perception of the worker changes with time. Normally, when you come to a worker who works in the assembly line and tell them, okay, we want to install a robot to help you on your workplace, they're very afraid they will lose their job. That's natural. But when they get the robot and they get to know it and they get familiar with it, and maybe if it's a cobot, they even work in the same space and they can touch it, then they just start to perceive it as a very helpful tool that helps them make their job faster, easier. Um, and yeah, they start to develop a relationship with it too. They also give them names and talk to it, and yeah, use all possible ways of communicating to it, including emotional, which of course it doesn't understand, but we try because it's natural for us. I think that's it.
Arina, that was really a great emotional way. Also, I mean, I already feel attached to our little cobot, which sits in our garage, so I can very much relate to it. And just talking to you a little bit in the morning, I kind of develop a personal relationship with cobots and robots. I'm very excited now that Tudor, he arrived. Train got unstuck. Tudor Ionesco is actually the head of the project CoMeMak. So COVID means makerspace. I'll hand over to you this one. You have the microphone. And yeah, over to you, Tudor. And you know how to make this. No, it should be on. And
Hello.
you just go back and forth.
Thank you very much for the invitation. Once again, just came from the train. Yes, I'm going to speak a little bit about the CoMeMak project. I'm sure you have already heard about it and also during the presentations. This presentation will be more from my own perspective than from the entire consortium. I will touch upon all aspects of the project. So we'll have a look at the motivation, the challenges, and the results. So the motivation basically started from the initial situation that human-robot collaboration in industry is safety relevant, which induces costs for industrial actors, users of these cobots. And we needed to flexibilize these norms, safety norms, because otherwise the cobots are not financially feasible. The cobots are also regarded as a socially more sustainable alternative to total automation because they keep humans in the loop. They offer opportunities for development for the workers and other employees. And there were relatively few cobots in public places in 2019. And we wanted to have a look at what the so-called do-it-yourself community would do with these machines, which are basically an industrial technology. So the hypothesis was that in large tech companies and usually corporations, where I also worked for many years, there are expert cultures and path dependencies which actually prevent innovative uses of new technology. So the question is, what kind of institution do we need to foster this kind of innovation, both to the benefit of individuals and also organizations? So just a very quick little history of cobots. So this is the first cobot that has been named as such, as far as I know, and patented. It was a machine that provided passive mechanical support to workers so that they can more easily lift things, such as a door for a car in assembly. And the first mentioning I could find was in 1996. It was patented in 98. Then starting with the year 2000, we had the cobots becoming more common and taking the shape of a conventional robotic arm, but with additional safety sensors. And you have here for us a famous image of Mr. Sami Haddadin, the founder of Franca Emica, the company, who has performed a self-experiment showing that cobots are safe. Now, 20 years after that, the cobots have become actually a consumer technology. You can order it yourself at home if you have the money. Today, I think you can get a good one for 4,000 euros. So like a Mac around that. So this is basically how we stand. Now, we wanted to go ahead and democratize cobot technologies. Cobot technology, including software, hardware, safety, in open machine shop, in public machine shops, like makerspaces, and kind of foster open innovation and crowdsourcing. And we knew that makers and hackers are creative, motivated, open to novelty, technically very talented, and much more than that. So this was the initial idea of the project. We wanted to go in the direction of developing new technology and educating potential future workers or employees or self-employed people. Now, yes, so here comes the interesting part. Sounds like an easy thing to do. Just take a robot, put it in a makerspace. Actually, there was a makerspace that had already done that in Berlin in 2018, where some people from the Freie Universität Berlin just put it in the makerspace and observed what was happening. That was not enough because not much was happening. So if you don't kind of help the people learn more about how to use the cobot, it will just be yet another machine. So the challenges in these projects, at least from my perspective, were the question of, for example, the question of who are the cobot users actually. I mean, you have a worker, a human working with it, but in a factory, the user is also the factory. So the question of risk and liability is shared among multiple actors. Whereas in a makerspace, we thought it might not be like that. So it is more, the risk is more pushed toward the individual who signs a risk waiver and so on. So, but these are all questions that we did not completely answer. So they are still valid questions now. Now, also in the makerspaces, speaking of open innovation, the question is who innovates and who benefits, right? So we have, for example, in the Grand Garage, an ecosystem of individuals, startups, larger companies, and if something is being created, the benefit is shared somehow, right? I'm going to skip the middle one because that's too complicated for this short presentation. An impression of cobots that at least I have gained is that they are fascinating, but when you start working with them, they're not so practical because they have their limitations, you know, especially in terms of software. You would expect it to behave like a human arm, but they are not really as good. And then one important challenge, I think, is something that this image suggests: an irresponsible user of a cobot. Who would do that, you know? And I think this cobot user model has influenced a lot industrial practices by expecting workers, other employees to be essentially irresponsible. So this, of course, has to do with insurances, with risk, distribution, liabilities, and so on. Factories don't want to assume any risks, so they need to do risk assessments assuming that users are completely irresponsible. Now, as for the tensions, we have tensions arising from these questions. So we have like dichotomies, individual or community versus organization. This is valid both for the factory and maker spaces. What is experimentation and what is utilization and capitalization, you know? So it is one thing to play with a robot, but it costs. So how do you capitalize on that? And there's a lot of discourses around this technology, which kind of contrast the practical uses. I'm sure Jesse spoke about these expectations of robots in general, but if you work with one, you'll get a lot of problems. So these are kind of the challenges and tensions that we tackled in this project, and as I said, they're not answered. So the follow-up project can easily continue with these questions. Okay, so I'm just going to quickly review the results. During the project, we found that in the makerspace, in the Grand Garage, we have responsible users, so not people who want to harm themselves. And there can be exchanges between people from different technical cultures, for example, professional researchers and just amateurs or laypersons, as we called them in the beginning. Now I would call them self-made experts or uncertified experts. And there's a lot of the diversity in maker spaces, which is good for the technology. And I think we demystified this technology, showing what are the potentials and limits of it. And now human-robot collaboration is an important part of Grand Garage's offer, which speaks for how one can capitalize on experimentation and exploration. And cobots in makerspaces are now an established model. So for example, we have here beneath the statue of Robin Hood, linked to a makerspace in Nottingham, England, that specializes on cobots. So they invested only in this, a lot of money. So, but we came first, so to speak. And then you have a list of results that is continually being updated. You can check it out on the website. And this is, for example, a new robot or cobot programming software, a web-based one that we developed during the project. You can access it online, use it for free. And with that, okay, thank you very much.
Thank you so much, Tudor. I have my own microphone.
I'll keep it.
Just there are so many questions that popped up in my mind during your interesting presentation, but I would like to take the first one from Slido because you briefly touched it. Do you think cobots could become affordable enough so that a lot of people have it in their workshop, garage, or even at home?
That's a short answer. Yes, definitely. You can already order cobots that cost like 500, 1,000 euros. They're not as precise as one that costs 20,000 euros, but you can do lots of things with it. The question is, do you really have an idea what to do with it and whether it is something productive for you or is it just playing, exploring a technology? Okay. So definitely yes.
Perfect. Thank you so much. I won't throw in the question about work, hobbies, and leisure time now because I think that would be too much. Yeah. But I wanted to ask another question related to what you said about safety and waiver to Chloé Nativel, who is another expert from RIC. She's a process development engineer. And I'll just, you don't need this one, you need the microphone, I think, from Tudor. Maybe you can elaborate a little bit more about waiver thing, safety issues. Is it safe to work with robots from your experience at RIC?
Yes, it is safe. On the one side, it's a quite new technology that people might not fully understand. It has been here for about 10, 15 years now. And on the safety point of view, it is safer than the industrial robot because it's in itself speed and force limited. However, it always depends what you do with it. If you add a gripper and effector, then it becomes a whole new machine, and then you have to reassess the safety. If you put a welding machine, then the robot becomes a welder, and then it has new risk, new challenges, and so I think there is a misconception that you can just bring a cobot here and put it there, program it without having additional safety devices. In most cases, it is important to have maybe a laser that control that people come in or not. It doesn't have to be physical safety, which with industrial robot you will need a fence because it is very fast and also carries very, very high loads. Uh, I would say so. Cobots are safe if you use it responsibly, if you make a risk assessment, if you prepare your whole project, and also if you are aware that this is still a mechanic device that needs to be used wisely.
Thank you so much, Chloe. I think that's a perfect just take it because the next person I would like to ask on stage then is Lucas, who is actually our host of Robotics here. And your aspects of saying you need to know how to use the machine, I think that's now the perfect time to actually show a little bit how we use the cobot in the makerspace. And I'll hand over the microphone to Lucas, who will now show our cobot in action.
Good morning. Hello, everybody. My name is Lomp. I'm the host here in Grand Garage for the robotics division. And yes, we're confronted in terms of cobots with completely new and different approaches in how to program or how to use a robot. So in the past, I was working in the industry with those very high precision and very fast machines. And it turned out that it's easy for a technician or for somebody who has like a basic education in technical fields. It's very easy to go via coordinate systems, manipulation, and building trajectories. But if you're working with people in a makerspace, you're confronted with people who are just curious in the technology itself, and they want to touch it and hands on it. And you just frighten them away if you talk about coordinate systems, if you talk about speed limitations or force. So I was thinking about a lot, how can we break the barrier down so it's much easier to use it? And so in a natural way, if you want somebody to show something or want somebody to do something, you just point there or grab the hand of the person, or maybe you stop it. And that's actually what's possible with cobots. So it opens up a completely different approach on how to use, how to program, and that opens up many new use cases and ideas. And for example, if I work with children or with younger people, it's very hard to say, do you know something about the coordinate system? Do you know the mathematics behind or the mechanics? And they say no. And so I asked him, have you ever played a PlayStation game maybe? And they say yes. And so we implemented a PlayStation controller for the cobot, and we can control the cobot with the PlayStation controller. Now it's disconnected, unfortunately. But we can move the robot and manipulate objects, and so they make their first experience by just a feeling to get the idea of controlling something. And then the questions comes up: how does it work? How do you do combining points to a whole movement? How can I activate the gripper or deactivate? How can I manipulate objects? And so you bring up the questions in terms of robotic on a much more natural way, and it breaks down barriers. And I even experienced a lot with people who are not, yeah, their mother tongue is not German or English. So how do you approach them to work with this object? And actually, it speaks its own language, so there is no need for any human language. It's just more about pointing, showing, and I try to teach them in Google Blockly. It's an open source programming language, and they can set it to their mother tongue and just get the idea of loops, of moves, of waypoints. And then we do the same on the robot. And we can also set up the language in a different language there. But most of the time, it's enough to show, press this button, move the cobot over there. And suddenly the people, they lose their fear. They start to be curious. Then I show them they can stop it by push it or force stop it. And so they try to really act like if it was an arm from a person. And it's turned out that's really fun because then suddenly the ideas comes up. Suddenly they say like, wow, can I use it for my camera to control, to make time lapse, or to do light wiring, painting, what so on. Things and use cases which are not really common in industry, but still they're working on a machine with the same capabilities. So you can use it like in the industrial environment, but also on this natural and very low barrier way. And yeah, it turned out to be really successful, especially with women. They're afraid. They're really afraid, and they sometimes they push it away like, oh, it's technical stuff I'm not interested in. And I tell them it's not about the technique right now. It's just about you and the machine, and try to interact with it. And suddenly you see them working like they do in a surgery or something. They go into small details, into small movements, and try to be very precise. And that's actually what the industrial approach is. But it comes up by a natural way. And that's much more interesting in terms of how we can use cobots for our purpose, but because it's not just a precision machine which is doing repetitively the same things again, but it's still a very much creative thing because it's has a lot of degrees of freedom. It can move around and it can do and manipulate whatever you want it to do, and not what some use case is telling you. And if you open this up and break down the barrier like this we did in the project, you experience a lot of smiles and a lot of people working with a technology they think is rocket science, and it's not.
Thank you so much, Lucas. One can tell you're really excited about having a cobot here and working with it in Grand Garage. Before this question, which actually relates to the part from yesterday, because he has prepared a couple of videos touching those, I wanted to ask Guido Breitenhuber to come up well, because he is coming from the programming side. And I know we have talked about it, Lucas, that we have a virtual fence to actually protect the cobot downstairs from the interaction. And I think, Guido, you have a lot to add to that, because my question is, will we still need experts like you doing the programming, or will this also be done by robots in the future?
Hopefully we won't need neither of that. So hopefully we don't need the expert programmers, and hopefully we can just make robot programmable or interactable with humans. And maybe I'm not so fascinated about robots programming themselves or robots programming other robots. But yeah, I'm Guido. I'm from JOANNEUM Research Robotics. We are in the field of industrial robotics, but very much working with collaborative robots. And basically our goal is how can we remove the fences between workers and robots and bring them together a little bit. And there's where programming comes into play. So why actually we want to have robots to be programmed? Actually that programming is the glue between all those components and making robots to work, because the robot itself, it doesn't has a purpose. So we need some program and we need someone telling the robot what to do, because we want to have these flexible machines and which can adapt to various situations. And how we were used to program robots in the past, it simply doesn't scale. So if we want to get them out and we want to have robots in public spaces and people interacting with robots, we can just we cannot just put a person next to every robot programming that task someone wants to do. So it has to become more and more natural. So we have here, or we see here, a cobot from Universal Robots. So it's pretty easy to robot, as Lucas mentioned. But I want to step one decade back, or one generation back. For example, the industrial robots. They're much harder to program. So you really need to have expert skills. Like Lucas said, you have to know the kinematics of the robot. You have to understand coordinate systems and things like that. And so in the time while you're programming this thing, I think you even haven't turned on an industrial robot because you're still doing safety briefing. So we moved a little bit forward, so it's getting easier to program the robot. So especially with the collaborative robots, they all of them have some sort of sensors in there that they can sense their environment, and we can use that for programming. So for example, for teaching a cobot, I can just drag and drop the robot in the real world and add some waypoints and actions there. But this is only the halfway we have to go. So it still feels a little bit unnatural to program robots, because literally we attach another device to it. So for example, this one, it's now hidden somewhere below there. It's the teach pendant, just a small computer with a display where we can type in some additional configurations, and we only just use the robot to move there with interacting with the robot to set the position in space, but nothing else. And this has to become more natural or more ubiquitous to really say, okay, we don't need programmers at all. I want to have people who are using the robot as a tool to also be able to program that. So because if I give you a screwdriver and you don't be able to use it, you won't use it. And that's the thing. So Tudor, for example, had a nice prototype where he abstracted this user interface away by giving voice commands to it. So you can literally touch the robot and drag it somewhere and then say, okay, this is the waypoint. I want you to go there and there. And this feels then more natural. And I think this also reduces the barriers between users or layman users and the robots. And yeah, so I think we are years away from having really good programmable robots that you program the robot by not even knowing that you program it. So that's the goal, I think.
Thank you so much, Guido. And
you don't need that.
I don't need that, no. I think everybody in the stream and even in the room could see it still needs humans right now to actually program, because Mikita, he is our expert in programming. He just fixed our cobot on the little tool which is on the floor. The people in the room can see it. He put in some codes, and magically now it's working with a joystick. I'm amazed. That's that's science fiction dreams really being reality to me right now. I would ask Jesse to come on stage again, because Jesse and I think we are now seeing the cobot in action, and I know you also have prepared some videos as well, which relate to the question that has been up on Slido for a while, and so interesting that I jump from one question to the next one. One of them is, would a vacuum cleaner be considered a cobot? And perfectly enough, you have scenario number 2 up there, the
Yeah.
vacuum robot.
You want me to show that one or?
I think it
Yeah.
would be nice,
Yeah,
yeah.
yeah, yeah. I mean, actually, I put especially a specific video of a vacuum robot, namely with a lot of interaction, kind of, with other beings.
Civilization's chance to make some new rules here. Is that should someone be trying to lead those discussions to figure out what it means for us to be the people of Mars,
Anyway,
the city?
well, I think so. I will connect that to this question. Yeah, I think I think there are two issues here. Like the first one, is it a cobot? So that's already quite specific. Is it a cobot, not a robot, but a cobot, collaborative robot? Then I would say no, because there is no real collaboration. If you have a vacuum cleaner, actually, it's a robot vacuum cleaner, right? Not this kind of vacuum cleaner, right? I'm just assuming that's meant by this question. Okay, yeah. So no, it's not a cobot because you don't really collaborate with a robot vacuum cleaner. But I had a very interesting disagreement with Lucas, and I would say that it is a type of robot, but Lucas was more from, let's say, the technical side. He was like, they are too simple things to be called a robot. So there we already had an interesting disagreement, because I'm coming more from this image side and the social side, like how do people perceive it. Then yes, I would say it is a type of robot because it has a certain autonomy. You can tell it to do something and it will do it autonomously. It draws a map on the floor and it does its job. But generally, this discussion about what is a robot and what not is a discussion that can be very long discussion. Like ask some engineer to give a definition of a robot and you'll get, ask 20 engineers and you'll get 20 different definitions probably. Also ask 20 philosophers who always like to define things and you will still get 20 different things. So yes, I would say it's a robot. The difference with the door holder is that the door holder is just a door holder. It has not much other function and no autonomy in that sense. So yeah, I meant the standard vacuum cleaner. Is it a cobot? No, absolutely not, because there is zero autonomy. You're doing all the work. Basically, it just has an engine that it sucks up the dirt from the floor. Do you want me to continue with those questions? I think there might be, especially the last one, might be better for somebody else who is more into the industrial use case. Ah, yes. You mean black?
I didn't. I wasn't a witness of the discussion, Lucas, and you heard about it.
We've
But
thrown
I
out
had
quite
an
a few
interesting
rockets. We have
introduction
there's
from
a whole compilation online that
Chloé
we put
and
together and others put
Arina
together.
on this topic,
It's
because what I understood, and maybe Arina, you want to come up again, or Chloé, to get the different categories. We talked about it briefly, that and I heard it from you, yes, and now that there is a very fluctuant way to categorize cobots and robots, and maybe that relates also a little bit to industrial use cases.
I can give you example of what we do with cobots, for example.
Let's do that, and maybe then Guido can jump in and add a little bit. That would be great. Excellent. We do it like this.
One example of our cobot is a screwing robot. It assembles doing the screwing parts, and so I'm not sure this is one of the most common application, because this is actually quite a complex application to do. most common could be pick and place, just like this, where you would have a robot in an assembly line picking up a part, putting it somewhere for the worker and assisting the worker carrying some load and some parts, and if it avoid repetitive task. I would say also it is getting more and more common. For us, there was only pick and place application or the screwing application. And now they are introducing it also into the quality sectors, where you would have two robots equipped with cameras checking the final device at the assembly lines. And so now there is no questions about the loads that it does or what it picks. It's more of a complex movement that the arm can do and that the human arm could do, but would be very time consuming and not very interesting for a human to do. Yeah, we also have a semi-collaborative mobile robot, which is AGV equipped with the industrial arm on top of it. So it's a hybrid cobot, I would say. It's has no fences like industrial robots. It's equipped with the laser scanners, which are triggered when someone enters the area or not. This is a very, I would say, uncommon technology. It's very new. I think from the company we have the robot, there is only 20, 30 robots out now. Most of them are used by universities. The industrial world is not so evolved in that yet. And we do an application where we load the machine, a CNC machine. Most of the time, this robot is used for logistics, so it drives around and go to his colleagues, human colleagues. Ours loads the machine and unloads the CNC machine, which involves a lot of problems, a lot of new technologies to use, and where we have to rethink a whole new philosophy about programming and what to do with the robot. So, yeah, common, but not so much.
Thanks. Yes, I need you, yeah. So I stress that. So first of all, what is a cobot? For me, the cobot is, so as we don't have a clear definition of what a robot is, I think we have a clearer definition of what a cobot is. So a cobot is this thing, a collaborative robot, which has one more feature than a traditional robot, and this means it can somehow sense its environment and react to this. And therefore, we can use that information in the robot control to make it more safe, so that we don't have to put a fence between the machine and the human. And what's now the use case for cobots in industry? So cobots means a collaborative robot. So there is some idea of collaboration behind that, and there are different categories. What is really collaboration, or is it cooperation, or is it coexistence? So for example, coexistence, we are now coexistence. We are both in our workplaces and don't affect each other, but there is no fence in between us. And then cooperation is things that we might do things together. So I do a task, then hand over to you, and you do a task. And the collaboration means we really do things together. And I don't see that in industry, because we spend years in industry on automation and making our processes so strict that we don't have many interactions between steps in this process. And now we're coming with collaborative robots and say, hey, let's throw this all away and make things collaboratively. And this doesn't work in industry, so in manufacturing, for example. So where I see cobots is they're used as replacement for industrial robots because they're cheaper. in situations where you need more flexibility. So because they're also easy to program, and therefore you can adapt those tasks a robot can do more easily. So I think this is why Chloe said in quality assurance, for example, there you don't have these things that have to run for years. So you want to handle exceptions there. But yes, what's your point of view on that? So for collaboration in industry and using really is do you see that use case for collaboration where really a robot is collaborating with a human on a task?
Currently, I think it's still quite difficult. Like currently, I think I am, for example, in an initiative where they give workshops, especially to, let's say, technical students. And I think from my perspective, currently, the aim is with collaborative robots is mainly to try to introduce them at a lot of places. I also put this a bit in my presentation, is accessibility and availability issue, uh, more or less in the hope that new use cases will be developed. On the other hand, I have also given a workshop at an actual company. They were producing heaters, and they were seriously thinking about introducing cobots in their factory because they didn't have so much space. So they didn't have space for fences and everything. But they did want to have more robotization in their factory. So their main objective was to see if they could have them working together, so collaborating with the humans in that also worked in that factory.
But this then meant as collaboration or just they coexist in the same space? Because that is one thing I often see, that you don't have the space to put a real robot and to have these safety distances to the fences, and therefore you say, okay, let's take a cobot, it's safe, and things are done.
Yeah, I mean, it's quite short, but yeah, I think it comes closer if you want to really put it in terms into cooperation, maybe. Yeah, where in those lines. Yeah. Lucas might like he's yes,
So to be honest, there is a lot of processes you can break down into small steps and then use high precision automation systems where you don't need a cobot. But there is also, like you mentioned, if you have the narrow space situation, where you then switch over to a cobot, but not because of its features actually, but because you can save space. But there is some, if it comes to complex mounting, and if you want to integrate the force control of a cobot, so especially if it's a really fine technology, really thin parts, you can then use the force and the torque measurements of the robot, not just as a quality insurance, but also for manufacturing. And sometimes you need processes where you would have to hand over to different robots or different automation stations because you cannot do the job on one part. And there is some collaboration going on where the robot is holding parts for you and you work together with it. But to be honest, it's still much more in our minds than really in the factories, because usually time is money, and therefore the cobots are not so good right now because we have to reduce speed and force when working with it together. So we need more dynamic safety related thoughts in how can we dynamically control speed and force from a robot. So it needs to get some more sensors for the environment. So if, for example, somebody's approaching the robot, it slows down to the limits, but if you go away, it maybe accelerates again. And then it's much more interesting for the industry because then it's also competitive time-wise, but brings the features for collaboration with it. But right now, I don't see so many really specific industrial use cases, unfortunately.
questions popping up on Slido. We have a little bit, maybe try to make the answers a little shorter, but you see it's so interesting. It's great to have so many different perspectives on the podium in the audience. I'm sorry, Mr. Soldberg. Can your question wait a little, because I would like to make the introduction to how about remote working, because that's a little bit what you touched, Lucas, and what's going on the podium. Is that a realistic scenario, that we are sitting at home and the robot is doing the work and we have the joystick and
It's definitely interesting and it's definitely going on, and we try to go in this direction, but there is still sometimes the need to push some emergency buttons or things like this. So you can do a lot of remote putting into operations and simulations beforehand. So actually, in most cases, you don't program the robot at the facility anymore. You do it online or offline at home. And then after the robots and the assembly line is constructed, you just put in the programs and then you try to fix the small minor problems which will then be there again. But for maintenance reason, definitely why not putting a camera going remote there? I think the pandemic situation the last years showed us that there is much more possible than we thought about it is. You have a question? Okay, you continue on this one, yes. But I can see it in the industry, it's really going on, and we are really focusing on this. So actually we developed a simulation which is running in on a web-based infrastructure. So there is no need to download programs or what so on, and you can actually use the real controller, but it's just emulated, but you get out the real programs you can then plug into the robot. So there's just this connection missing that you do it online live, but it's not a big deal to do.
Sounds very cool. Arina wanted
So
to
it
add
might be
something.
a big deal if you don't have the models of the environment. So yeah, so what you have to have is this digital view of your workspace, which is sometimes not that easy to get.
If you don't mind, I will address both of those questions. About the remote working, yes, it's definitely. Is this working? Okay, good. It's definitely happening. For example, we use robots in very dangerous spaces, like in rescue operations, in nuclear facilities, when we need to work with nuclear material, then we can do it remotely, of course. This is a common use case, I would say. I don't know if it makes sense to control a cobot remotely, because the cobot is meant to be already working with some humans in the immediate vicinity. But yes, it's realistic. It's happening. Common practice. I really love your nickname, Dr. Zoidberg. And my answer is, well, you have to think about it yourself. But normally robots, at least in industry, they're used for repetitive tasks. So maybe you can think about things that you do automatically. For example, when you open a when I open a kitchen cabinet at my mother's place, then I often try to open it the wrong way, because my kitchen has different handles. And when I try to open it, I just make a mistake, because my body is trained to do the same movement every day. So maybe we can think about this. Or for example, I'm interested in specialty coffee, and I make a brew every day, and it's a very it should be a very precise movement, but it also needs to be consistent every day, so you get the same quality at the end. So maybe you can automate that. So yeah.
Yeah, we were just talking about who can answer the next question, because I feel all of you can answer it, but maybe also Tudor Ionesco can give us his thoughts on the possibilities of small and medium enterprises trying out cobots.
Yeah, I think this is one of the main marketing propositions of cobots, that smaller companies where everybody knows everybody else and employees are, you know, well trained. There are direct communication channels. They would assume more responsibility than the workers in a large factory. So it's always the question of how much risk you the use of a cobot entails for the individual and for the company. Now, for the versatility of what can be done with it, I think smaller companies will probably decide on their own, on the use case, on a very specific situation, whether a cobot makes sense or not. So I think that's, you know, up to the small company. I will not say that the idea that a cobot is perfect for a small and medium company is something that goes without saying, so to speak.
I'll add something to that. Yeah. So to boil it down, for sure, you can try cobots. For example, just get a membership at the Grand Garage, and there is one cobot, and you could try this out. We also have a space at our institute in Klagenfurt where companies can come in and try out solutions without having to invest much money to buy the equipment themselves to then figure out that it doesn't work. So we are offering that as a service. And maybe RIC is having some similar things with teaching and educational focus, but I don't know exactly.
I'll come up and switch the slide from the last one, because we just saw that we have, fortunately or unfortunately, the wrong hashtag. It's not TechBrunch, it's CoMeMak, but we see people are already using CoMeMak, so maybe there are a number of more questions on the TechBrunch. We'll check that one. And I think this slide just is important to see as well, because I've only briefly introduced each and every one of you, but this shows also the broad spectrum of the CoMeMak project. There are really a lot of experts and companies involved, and we all have them here for the first time, I think, in person, all of them in one room. And we are very excited to see the lively discussions this creates and the questions that are coming in. And I'm not sure the last one probably is again a question for every one of our experts in the room, even on the stage. So I leave it to you to choose who will answer it. Is the simulation aware of its environment? Can the cobot hurt itself or the environment? And how about the real-time crash prevention? How far is the technology?
So on how much effort you want to invest in a simulation that really reflects reality. We always have this reality and simulation gap, which either makes things or abstract things too much, or are going into too much into detail and doesn't go hand in hand with reality. So usually the simulation is aware of the environment, so you have some sort of physics simulation behind that, and if you have objects in there, the simulation recognizes if it's hitting some object in the scene. So yes, the cobot can hurt itself. So this is also one big part of general safety. It's not only about being safe as humans from the machines. It's also about being safe from damages in the environment or the machine itself. So the controllers usually know where the robot is and also detect these things. And this can be a real-time crash prevention, at least for the robot, because it knows beforehand he hits itself that it will hit itself and stops the movement. Then the real-time crash prevention. So it's code alone, no, because it's just sensing that some force is going or is there is some pressure or force applied to the robot. So there's this is already too late. So then I already hit something. But for example, we are working on some sort of skin which really has some near field oversight that you can, for example, measure at half a meter when you're approaching something and the robot could stop. And usually for now in industry, you have some external sensors like laser sensors or cameras or things like that give an overview to the scene, and then having a simulation run besides the actual execution of the robot, so that you can for example, evade some obstacles.
Just, I think this is a very good question, and it will concern us for a long time. From my experience, the crux is the problem that the environment is infinitely complicated or complex in a mathematical and physical sense. So to give you just one example, if you want to precisely pick and place things that are small, you need 9 decimals or more in your positioning. And this cannot be represented in simulation so as to match reality. So the key here is to create affordances or tolerances in the simulation, and to kind of create mechanisms that, you know, deal with the bureaucracy of nature, if you will, so the infinitely complicated things that are around us. And this is one point where machine learning is expected to help with that. But I think we're still a little far from that. And we forgot one project partner.
We forgot the
RIC,
RIC. Yeah, that's
who is
what we
very
just
important
figured out.
for the project.
We are very sorry for this, but we are so glad that we have two excellent representatives here. And yeah, I think Chloé, Nativel, and Arina, Lomp, yeah, they gave us so much information on the RIC that, yeah, apologies. Slido, I would say last chances for last questions, or maybe from the audience, there are questions still popping up. If not, I think we have really gotten a great and very varied overview of cobots, and we all got a good understanding how difficult it also is to draw the line between robots, cobots, and what they can do for us. I think the future is very exciting when it comes to it, because there will be lots of developments still coming up, and we are right in the middle of it with the CoMeMak project. And everybody stay tuned at CoMeMak.at, and also Grand Garage EU as well. We'll keep you posted on everything that's going on this end. And if there are no question coming up, I would like to thank each and everyone who contributed today, all the presenters, all the experts, but also the whole team of the Grand Garage to make this work. And I wish you a very nice Friday and a great upcoming weekend. And for us, it's now time to brunch.